So we are going to get into some random variable things. So if I'm talking about random variables, you need to know what that means. So we'll start with those definitions. A random variable is just any numerical measure of the outcome of a probability experiment. And it can be discrete or continuous. Discrete is countable, 1, 2, 3, 4, 5, those kinds of things. Continuous has an infinite number of values. We just need to practice looking at some examples and knowing if things are discrete or continuous. You know, discrete is a countable number, so it would be like standing in the parking lot and counting how many people wear their seatbelts as they leave. Okay, you could make a list of every possible value, 1, 2, 3, 4. If I'm talking about like the amount of time it takes before a touchdown is scored at a football game, that would be a continuous value because I couldn't really list them all out. You know, you could measure it in minutes, but we could do seconds, or couldn't we do like decimals? You know, 1.3 seconds, 2.345 seconds. So like time would be continuous. If I'm talking about weight, that would be continuous because we could always have more decimals on it. Like height of an object could be continuous because you could have decimals. So anything that's allowing for those decimal values would be a continuous type answer. So if I just looked at these and I want to know if these would be discrete or continuous. If I'm talking about the number of light bulbs that burn out in a room of 10 light bulbs in the next year. So would that be discrete or continuous? Discrete. We could count how many light bulbs burn out. Okay. And I asked you to list the possible values. What would be the lowest possible number? 0. We could have no light bulbs that burn out. Or 1 or 2. What would be my highest? 10. So I could get any answer between 0 and 10. B. The number of leaves on a randomly selected oak tree. Is that discrete or continuous? We could count them. Probably don't want to, but we could. So my answers, could it have 0 leaves? Yeah, 1, 2. Does it have a maximum number of leaves? No, there's no rule that says an oak tree can only have 300 leaves. Okay, so it could just keep going forever. We don't really know what the stopping point is there. C, the length of time between calls to 911. That would be continuous. Time, weight, height, those are your continuous type things. So my answer, what kind of numbers could we get? Anything positive, anything bigger than 0, right? Could we have 0 seconds between calls? Yeah, so anything greater than or equal to 0 would work here. Do you guys understand the difference between discrete and continuous? So with these, we can make probability distributions. We saw those before. Remember, in a probability distribution, we have every possible outcome and its probability. If it's a probability distribution, there were 2 rules. Every probability has to be between 0 and 1, and they have to add up to 1 altogether. We can really only make those right now for discrete variables, so our focus today is going to be on this discrete situation where we have a countable number of values for an outcome. So let's make a probability distribution. So suppose a basketball player is asked to shoot free throws. I want to create a possible probability distribution for 0, 1, 2, or 3 shots made. All right, so we shot 3 shots, so we could make 0, 1, 2, or 3 of them. This one is a pretty generic. I'm just asking you to make a possible probability distribution. Did I tell you what the probabilities are? No. So you get to make them up. But the key is, when you're done, what do they have to add up to? 1. And every number has to be positive. Okay, so make up some probabilities. What do you think the probability of making none of the shots would be? 0.1. Okay, give me a probability for 1 shot. 0.25. What about 2 shots? 0.5. Okay, do I just get to make up a number for 3?
No,
how would I find it? Okay, so 1 minus each of those things, because I know my total probability is 1. So what's my probability for the third, making all 3? 0.15. Okay, so we just totally made up our probabilities, but we're just practicing understanding what it is. It has to add up to 1. So I'm going to put a couple up here, and I want you to decide if each of these is a probability distribution. So you can just take a second on your own, look at them. Is the first one a probability distribution?
No.
Why?
It doesn't add up.
Doesn't add up to 1. What about the second one?
No.
Why?
Negative.
Negative probability. What about the third one? Yes. Every probability is between 0 and 1. Could you have a probability bigger than 1?
No.
No. And they add up to 1, so that one is a probability distribution. Okay, so when we have a probability distribution, I could ask you to draw a graph of it to kind of describe the shape, and I think one of the homework questions that I'm going to give you has a graph and just asks you to read it. So I just wanted to make sure we could draw and read one of these. So here is a probability distribution. I want to describe the shape. So to describe my shape, I'm going to draw a graph. I didn't really specify what kind of graph to draw, if you wanted to do a bar graph or a line graph or what. I'm just going to keep it pretty simple. What would go on my x-axis? Which numbers? Yeah, our x values here, the 0 through 5. This is the number of movies in this scenario. Okay. And my y-axis would be my probabilities. So maybe I'm going to count by, I'll count by 0.1s. So we had 0 movies, 0.06. So just a little bit over halfway here. I'm just going to do it just a dot and then draw a vertical line to it. 1 was 0.58, so that's almost 0.6. And again, you could do a different kind of graph. I kept it pretty generic and just said draw a graph. 2 is 0.22. 3 was 0.1. 4 was 0.03, so definitely less than half, and 5 is 0.01. So very tiny there. When I'm talking about describing the shape, I'm talking about symmetric, skewed left, skewed right, like we did before. So I can see my high point is right here, and we have a lot of points going to the right of that. So this graph is skewed right. You know, if you drew that curve over the top, it peaks here, and then the right tail kind of goes on forever. So there's more low points, it's skewed to the right. And I could give you a graph like this and ask you to estimate probabilities. You know, if I said, what's the probability of watching 3 or more movies? What would you do? Add your 3, 4, and 5, either from the table or from the graph. If I said, what's the probability of watching less than 2 movies? Add up your 0 and 1. So you could just use those probabilities to answer questions there. All right. So far, so good. Grab your formula sheets, please. All right, so it would be useful if we could find the average from this type of distribution. And there is a calculation for the mean or the expected value in a discrete probability distribution. So I might ask for mean, I could ask for expected value. Your formula sheet has that in parentheses, so they mean the same thing. And what we do is, do you guys remember what this symbol means? The sum of x times p of x. So we have to add up the values of x times the probability. So let's find the mean for that distribution I just wrote down. Okay, so we drew the graph for it. Here's our calculation. These probability distributions are given to us in a table most of the time. And so the easiest option is just to add another column to your table. So we already have an x and a p of x column. The third one is going to be x times p of x. And so what we're going to do is take those numbers and multiply them together. Are you guys done? So I need another column here. And we're just going to multiply. So 0 times 0.06 is 0. 1 times 0.58. 2 times 0.22. 3 times 0.1. 4 times 0.03. And 5 times 0.01. And so then to get the mean, we just add all of those up. So what this is telling me is if I pick the person, I would expect them to stream 1.49 movies a month on average. That's their expected value, or the mean of the group I looked at. If I just take a sample of people, is their average probably going to be 1.49? No, this is what we would expect based on everybody's data, but we know that if we take a sample, usually it's different than the population. What would make that sample closer to the population? a larger sample. The bigger your sample is, the closer we would expect it to get to this number, the expected value. Okay, let's look at, I'm going to skip to this question. All right, so suppose a life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $530. The probability the female will survive the year is 0.99791. Compute the expected value of this policy to the insurance company. So this is actually something that is done. If you are an actuary, they basically work for insurance companies and decide, okay, based on this age, this health risk, what should the premiums be? Because their goal is to not lose money, right? Even with your auto insurance, they look at lots of different factors and try to decide, okay, how big of a risk are you? How much should we charge you so that we're not losing money in the end? So we have to be able to take this and figure out the expected value is how much does the life insurance company expect to gain or lose in this scenario. We can do this by making a probability distribution and finding the mean. Expected value is the same thing as mean. So we need an x, we need a p of x, and then to get the mean we have to multiply those. My x, those are my possible outcomes. Okay, either they pay the life insurance or they don't. What makes them have to pay the life insurance? If the person dies. When do they not have to pay the life insurance? If the person lives. So those are my two outcomes. They either live or they die. Okay? So if the person lives, let's kind of talk about it like this. We can't just say, you know, lives is 1 and dies is 2. We have to think about what does this mean to the insurance company. If the person lives, X is like the amount of money. How much money does the insurance company make if the person lives? They make the $530. So their X, they get to keep the $530. That happens if the person lives. What is the probability the person is going to live? Okay. The other outcome is the person dies. If the person dies, what happens to the life insurance company? They pay the money, so they lose money, right? They have to pay out $250,000. But keep in mind, they did at the beginning of the year collect $530 from the person, right? So how much money do they actually lose in this scenario? Right, you would have to subtract the 250 minus 530. And since they are paying it out, it's like a loss. So 249,470 would be the amount of money they lose. Does everybody understand where that number came from and why it's negative? Okay. What's the probability that happens? Yeah, you just have to do 1 minus this, it's just the complement. All right, so that's the hard part. Now we just need our mean. So we multiply. And then to get our mean, or the expected value, you just add those two numbers together. So their expected value is $7.50. They're expecting to make $7.50 off this person. Okay, if there's only like 10 people that have this policy, does that work out? No. I mean, if there's only 10 people and they have to pay out, they go under, right? This only works if we have a large number of people that participate in this policy. And so then if you have that large number of people, then you would expect to make about $7.50 for everybody that participates. It is a lot of money, huh? Okay, the other calculation that we can do with this is standard deviation. If you look on your formula sheet, you have two different formulas for the standard deviation. They look kind of nasty, but if we break them apart, it's not too bad. The easier option is the second one. So we have the x squared times p of x minus the mean squared. So we'll have to do a few calculations there. So I want to practice doing a standard deviation by hand, and then I want to show you how to do it on the calculator, and then I'm done for today. So let's go back to the one that we did, where we found our mean. I'm going to run out of room, aren't I? We need an x squared p of x column. Okay, we don't really have to go through and do a whole lot to this. X p of x, to get x squared p of x, all you have to do is multiply it by x again. So really what I have to do here, you can either go through and square this times probability, or you could just take your probability times the x one more time, and that would give you x squared p of x. So if I multiply those numbers, so then what we have to do for our standard deviation, we have to do the square root of the sum of the x squared p of x's, and then subtract the mean squared. So my x squared p of x's, if you add this column, what does that add up to? 3.0 minus my mean was 1.49. That's supposed to be a square. I don't know why I wrote it as a subscript. Squared. So on your calculator, I'm just going to type it all in. The square root of 3.09 minus 1.49 squared. And we get a standard deviation of 0.9327. Any questions on how I got to that one? So let's talk about how to do it on the calculator, because we know a lot of these things, if you do it on the calculator, it's more efficient. So on your calculator, you need to go into your lists. And I want you to enter your X's in L1 and the probabilities in L2. Then we are going to go to Stat. We want to calculate. Even though we used both lists, this is still one variable statistics. But here's what we're going to do. Our list is L1. The frequency list is going to be our probability. So we want that to be L2. So if you just hit second and the number 2, you can set your frequency to L2. So your list is L1, frequency list is L2. And if we hit enter, then our mean is X bar 1.49 that we got. Standard deviation is the sigma, 0.9327 that we got. So we can do these by hand or on the calculator. Questions there? Yes.
How do you guys say it's?
Okay, so you got it all entered?
It's just X and
Okay. Yeah, so you enter those, so then we go to stat. Actually, then calculate one variable statistics. That's the same as this, we want to be L2. And then just hit enter. Alright. So let's try a few of these. Let's do. Several of them, like it will say find and interpret, just like I've been doing. You don't have to interpret anything, just find